welcome to this webinar. So today I'm here with Roxana. In my case, I am Mimi, a data scientist, and we are going to show you how we build smart product recommendations by combining Oracle Apex, OCI, and OCA Data Science together with Oracle Database AI26 AI. So the idea today here is simple. So instead of forcing users just to type the perfect keyword, we are going to let them search by similarity. So for example, we will say something like, show me things that look like this, or find something like this description. So we are going to show you how we did it, and we will walk you through the problem, the architecture, the models we use. And then in the hands-on, we are going to generate embeddings, query them with SQL, and then we will use Apex to explore the results. Before we dive in, this is just our quick safe harbor note. You know that some of the things that we will mention are touching some Oracle's product direction. So basically, we are saying that everything here is for information purpose only and shouldn't be taken as a binding commitment or any contract. Here, the agenda for today, this is how we are going to spend the time. On the presentation side, we are going to explain the problem just in one slide, why classical search isn't enough. Then we're going to show you what we built, a query by image experience for a fashion catalog concretely. Then we are going to look at the key technologies behind it, which are Apex, of course, OCI Data Science, Oracle Database 26 AI for vector search. Later, we are going to zoom in on the embedding models that we were using, and then we are going to connect everything into the end-to-end architecture and flow, and we will close it with some next steps and ideas for personalization. On the part of the hands-on side, we are going to show you how we generated embeddings in data science and how we load them into the database 26 AI. Then later we are going to write a bit of SQL with vector distance to validate that it actually works. And we will use the Apex application to do query by image, and we will see the ranked results. If we have time, we are going to touch a bit on user profiles and natural language filters. And finally, of course, you remember that you can make all your questions in the chat. So let's start. We're going to talk about shopping experience. So you know that in theory, search is very easy. You just type what you want and then you get the right item. So in practice, we can say that shoppers don't know what are the right keywords. So instead of typing, give me the blue summer top with palm print, for example, we are going just to type blue t-shirt, and hopefully we are going to find the best. So on the retailer side, manual tags are usually, incomplete or inconsistent. Some items are only tagged by blue, some as navy, some maybe are missing, some are casual entirely. So that means that the catalog is not fully describable, and they are not describing what the user are seeing in the picture. So at the end, we have some users that are frustrated, that are scrolling and only checking page of results. So what we really want is this. Find me things, for example, that look like this. Can be based on an image or natural language description. And then we need that to be fast, accurate, and scalable. So this is exactly our problem that we are going to address with vector search and recommendations. A bit of a high level, this is the solution that we are presenting today. We have basically an end-to-end pipeline that is starting in data science, that it's moving into the database AI26 AI, and it's coming up to the front end with Apex. So just for going a bit step by step, first, we use data science for processing the catalog images and generating the embeddings with, in this case, ResNet 50, but can be used any model. This is going to give us a dense vector that is going to capture the visual features for each product. Then we're going to store these embeddings in the database in a vector column, and we are going to use vector distance in SQL to find the closest matches. And on top of that, we build the Apex application where a user can upload an image or select an item from the catalog. Then the application is going to call the SQL query, retrieving the nearest neighbors, let's say, and show a visual grid or similar products. Plus, you might also like, this is something that we added, like recommendations that are based on your history. Then also optionally, just to add that you can plug in a model that generates automatic descriptions and categories for each item. So it's going to help you to enrich the catalog and improve the search. So from the user's perspective, you just need to upload a picture, get smart recommendations, and behind the scenes, it's Oracle database who is doing the vector search with embeddings coming from OCI Data Science. Sorry, because here something is missing. Some picture was removed. But well, basically here we wanted to talk about the key technologies one by one. The first one, it's about AI vector search. I don't know why this appeared, but we had a bit an schema. Oh, sorry, it's here. Sorry. It was not working the click when I was the automation, let's say. So sorry, here we wanted to show a bit the key technologies. The first thing that we are mentioning is AI vector search. So here the idea, instead of comparing raw text or raw image directly, we are going to first convert each object into a vector embedding. So basically, you know that a vector is a list of numbers that it's capturing the meaning or the visual appearance. So the flow looks like this. First, we start with an input data object. This could be an image, a title, or free text description. Then we pass it through an embedding model, which is going to give you as an output a vector. And then we are storing those vectors in the database and use vector search to compare them with the existing catalog vectors. And of course, finally, what we are going to get as an output is the top K matches, at the end, the items that are closest in this vector space. So we are going to show the most relevant content. So here, the most important point is that we are searching by semantic similarity, not exact keywords. So if two items are feeling like similar to the model, they are going to be close in vector space, even if the text labels are not matching. And then with that, we are going to enable features like search by image, find similar items, and more intelligent recommendations. The second thing related with technology that we are using and we wanted to show a bit, it's around the models. In this experiment, in this demo, we are using several models, and each of them have usually different role play, let's say. So we are combining 3 different embedding ones because one could be good for a specific type of question and the other one for another one. In that case, in this picture, you can see the ResNet schema, but we are using ResNet 50, Clip Bit L14, and Mini LM ONNX. Just for summarizing a bit, ResNet 50 is very good in a strong visual feature, so we are using that one only for pure image to image similarity. So basically, just find me images that look like this picture, and then it's going to power the query by image part. The next one, Clip, we use it to train to align images and text in the same vector space, which means that we can do search by description. So we can type a phrase like high-waisted light blue jeans, and we are going to retrieve matching images or go to the other way around, like image to text. And in this case, it's very good when users are coming with words instead of a picture. And the last one, Mini LM ONNX, the L12 version 2, that it was converted to ONNX. This one is very fast, text-only encoder, and we can run directly inside ADB as a ONNX model. And we use it for semantic search on titles, descriptions, and for lightweight text-based recommendations. So things like people who view this also like, also of course based on product text. So in summary, ResNet for lookalikes, Clip for image text queries, or in the other direction, and Mini LM for high-speed text semantics inside the database. The next thing that we are using that is very relevant is OCI Data Science. This is going to be basically the main data science workbench, but just to clarify that, of course, you can prepare your vectors in locally or in any other framework that you prefer. In that case, we are using Oracle One in OCI, of course. In this case, just for explaining what you are going to find in this service. It's designed for being accelerated. We get managed Jupyter Notebook sessions. We can access to GPUs and CPUs and tools to automate workflows. So we can go from notebook experiment to production much faster. It's collaborative, so if you're a data scientist, you can share your projects, your environments, and models in an structured, secure way. Inside, we have features like model catalog, feature store, jobs, pipelines, deployments, and all the machine learning operations pieces that you could expect. It's enterprise grade, so it's running on OCI infrastructure with enterprise security, of course, with networking and integration with other Oracle services. And here, the key point for you as a developer is that you can keep working with your favorite Python and open source libraries like PyTorch, TensorFlow, Hugging Face, but within a managed platform it's integrated with Oracle Database and Apex. To continue a bit explaining this technology, you can see that you can use data science for the full machine learning lifecycle. You see that here the 4 steps. In case for our demo, we are going to start with preparing the data. You can connect to any data source. In our case, it's going to be the product catalog and the images. We're going to prepare them from the notebook, and we can even use serverless Spark via OCI data flow if we need distributed processing. The second part is developing, so we can develop the models in the Jupyter Notebook sessions. We are going to use the ADS SDK, which is a standard Python libraries, and whatever open source tools we need. And this is where we train and tested the ResNet and the models and generate the embeddings. The third step is managing. So once that we are happy, we are going to register them in the model catalog. We are going to manage the content environments, and we will keep track of projects and versions. So it's going to make it easier to reproduce results and be able to collaborate. And the last part, of course, operationalize. We need to create jobs, pipelines, model deployments, and we need to set up the monitoring. So in this case, in this demo, we are focusing mostly on the jobs and the database, but the same platform can serve as the real-time inference for production applications. So across all these stages, we are having an open source at the core. So the skills that you are using are the same as in any modern data science stack, just integrated tightly with Oracle. To see a bit the difference between the normal or the infrastructure management that we know in local projects and between with data science, here we have this comparison. It's completely 2 different ways to do the GPU-based machine learning on cloud. So on the left, you can see that we are using OCI GPU plus virtual machine plus OKE. So you are managing everything: Linux images, NVIDIA drivers and CUDA, containers, content environments, all the networking, the security, and even the model itself. On the other hand, in the right, you can see OCI GPU plus OCI data science, and here the infrastructure and the management are handled by the service. So you pick a notebook, shape with GPU, the service is managing the base image drivers and integration, and you can focus purely on your code, on your models, on the data, and not writing the platform together and prepare everything since the minute 1. So for this recommendation demo, we choose, of course, OCI data science because we approach this mindset and we could spend our time purely on embeddings, on SQL and Apex, rather than CUDA and OS configurations. And with that, I'm going to pass the voice to Roxana, that is going to guide you through this Converge database, Apex, and the detailed solution.
Thank you, Christina. Hi, everyone. I am Roxana. I'm a data developer at Oracle. Let me quickly share my screen. I hope you can see it. Okay. So, Christina covered the data science part and what she is doing to process the images, but we need to save these images and the data somewhere, right? So the best place to store these images is, of course, the Oracle database. Oracle AI Database 26AI is a converged database, meaning that it supports multiple modern workloads and data types natively. So instead of having separate silo database for different scenarios such as machine learning, spatial, REST, graph, JSON, vector, whatever else we have a single engine that supports all the workloads. And this is Oracle AI Database 26AI. And the best part, all of these features are included at no additional cost. For today's demo, we generated embeddings both from OCI Data Science, but also from the database. So we can generate these vectors inside the database using the models. To generate this in the database, we used in the first place OML4Py. OML4Py is machine learning for Python. It's basically a Python API that supports the machine learning process, including data exploration, preparation, machine learning modeling, solution deployment, and so on, using your Oracle AI database. So on this slide, I'm showing how we can bring our own transformers into Oracle database using OML4Py on an AX pipeline. And I hope you can see the screenshot that we added on the slide. We have the OnNX pipeline class that is part of OML utils. So what we can do, we can take the Hugging Face transformers and automatically convert them into portable OnNX models. This is the format that we support in the database. We capture all the pre and post processing logic, organization, padding, image resize, normalization, and so on inside the same pipeline. Then we either save the model in the database for the runtime inference or export it to a file like you can see in this example. And we have, if you take a look on the first example that we have there, we create an OnNX pipeline with a model name like AllMiniLM. This is for fast text embeddings. We call the export to DB function to deploy directly in the database, but we also call the export to file to keep a local bundle in case we need it later. And we do exactly the same steps for the other model that we are going to use today, the clip. This one is used to get image text multimodal embeddings. So as you can see, with just a few lines of Python code, we can reuse standard Hugging Face models and run them inside of Oracle AI Database 26 AI and get them ready for vector search. Now, we have seen how to create these bundles directly from Hugging Face. Here, we look at a second path. We can import an existing OnNX bundle into the database using the same OML4Py. So we have in the version 2.1, we have an OnNX class that will let us to point to an OnNX file on our local file system. This is, as you can see in the first example, this is the name of our model. And describe how we want to use it, the mining function. We are using it for generating embeddings, and then which is the model input. In this case is text data. We do the same for the clip. We are using also for embedding, but this time we will map to images. So whether the OnNX file was produced by OML4Py, another tool, or another platform, we can bring it easily to 26 AI and use it for generating embeddings. So we have the data, we have the embeddings, we have the database. Now we need a way to show the data to our users, right? And let them interact with it. So for this, the best option is Oracle Apex. This is a low-code application platform that enables you to build scalable and secure web applications anywhere, either in cloud or on premises. It is part of the Oracle database, so if you already have Oracle database, you have Apex at no additional cost. There are plenty of things that you can do with Apex. You can quickly build reports, forms, charts, calendars, and so on top of the data. It's super easy. You just need a web browser and you will log into the development environment. It has a declarative format. It stores everything in the database. There is no need to generate or compile code or something like that. And if you know a little bit of SQL, then you are ready to start. Of course, security is an important part, and Oracle Apex is designed to build secure applications out of the box. We have server-side management that is used for a user's interaction with the application. We have built-in timeout that will end the session when the user is away for too long, checksums, and so on. But it also provides seamless integration with most of the Oracle database features, and in this case with vector search. And for this, we have vector providers and APIs that we can use to leverage these capabilities. And you see on the slide an example, Apex_AI get vector embeddings API that can be used to easily generate vectors from the data. Now, this is how our demo looks from end to end. The steps are very easy. We have the data, we load the images, we process them in data science, we resize them, convert them into base64. We embed them in batches using the ResNet 50 model, and then we insert everything into our database 26 AI. But the beauty of this database is that we can store the vectors alongside with other data types, because we need also descriptions of the products, categories, price, and so on and so forth, information that will help in our application. Then once we have the data in the database, we start to query them at runtime using embedded functions like vector distance and get the top results from our database. And here you can see a short preview of what Christina will show you, how she processes the images, how she prepares the model, define the image processors, and generate embedding in batches, and so on. And you can even run a similarity search from OCI Data Science and test the model. Then in the second part of the demo, we will show an Apex application, and we have designed 3 main pages. First of all, some of the times we want to search for a product, but we don't know how exactly to describe it, or maybe we already have an image that we want to find something similar. So this is very easy to implement. The user will upload the image. What we'll do, Apex in background will generate embeddings for that image, and it will compare that vector to the existing vectors that are in the database, and it will order the results by vector distance, giving the top N results. But not all the time we want to search by images, right? Sometimes we want to search by description. So let's say we have a party and the theme is flowers, so everyone should come dressed with flowers. So we go to our preferred online shop and we search by flowers. So what we've done here, we generated embeddings from the product descriptions, like this one. And once we search here by flowers, we convert this into a vector, and we compare this vector to the description vectors that we have in the database, and we will get the closest result. Also, in most of the online shops, we always see something like, you might like this one, or this is something that is frequently bought together with your item. So this is what we also did for our demo today. Once you select a product that you like, you add it into your favorite or into your cart, we are starting to build smart recommendations, meaning we find similar products, and this is based on image vectors, and we recommend you products that are similar to the one that you already have in your favorites. This will help you to discover more items that you might like, or items that can work very well with what you already ordered. But enough with the slides. Now let's see the demo in action. Christina, do you want to start with preparing the data?
Let's start. Let's see the funny part.
Okay,
Thank you, Roxana.
let's see.
You should see.
All good?
All good.
Yes.
Okay, perfect. So in this part, we have prepared a notebook in data science for preparing the images and making the embeddings. So we're going to explore specifically how we can take a catalog of images. In our case, are all homemade, by the way, all done by the specialist team in data development. So thank you so much for the collaboration. You will see then later some funny pictures. We are going to embed them using the open source model ResNet 50, as I mentioned before. And yeah, we are going to store them in the database to perform later the similarity search across the image catalog. So we're going to use the first thing, very important, Oracle DB Python SDK to interact with the database and also with the AI vector search capabilities. So the first step, of course, is taking all our pictures, making imports related with the functions that we are going to implement. So the first important steps is loading the images all together to be able to make embedding. So here just we are preparing the image catalog, so it's in a clear and tabular way. I'm pointing them to image direction, to the dataset folder, and you can see that here we have 99 images. It's a very small demo, but it was enough for making good results on the vectorization. Then, of course, we are adding the full path for each file. We are going to add the type label to set the clothes, and then I reset the index to create a numeric image ID that will later reuse in the database and in Apex. And then some preview that everything is loaded. So once that we have the images, of course, we need to prepare. So we know that we need them for both for modeling and for the database. Here in that case, I defined two small helper functions, very simple. One is only for resizing each image to a target with while we are keeping the aspect ratio, and another one for converting a P image to base 64. So we can store them as text or send this to the APIs. And then, of course, we have this function, process and save images, that is going to loop over the rows in the image data frame. We are going to use these utilities to create a resized GPG for each file. We are saving them under a resized images folder, and we are also going to write a base64 file with the base64 string. You can see here in the left in the memory of our session that we have all the pictures ready. This is basically what we did. And of course, here just defining the base path where we are going to store and save all the images. The results are a data frame with the ID of the image, the file name, of course, the path where we have the picture, the type, in this case, all are clothes, and the base64 code. Inside this preparation of the data, we have another important step, which is turning every image into a numeric vector using a pre-trained ResNet 50 model. So what I did here basically is just to load the image preprocessor and the ResNet model, and then I auto-detect the device, so in case it's using GPU, if it's available, and otherwise CPU. The helper function in this case is the generate embeddings in batches, that is taking the list of PIL images, are processing them in batches, and it's letting the processor handle resize and normalization, and then runs a forward pass through the model under the torch.notgrad function to get the output logics. So here now the result, we have finally our vectors for each picture from the base64. Another step that it's recommended, but it's not obligatory, is to add some image description and category. This is going to help later on the part of making some queries with text. So as we have already the base64 column, I can send, for example, its image once to a vision model. In this case, I use OpenAI. For that reason, you will add an OpenAI key, but of course, you can use any other model. And what is going to return, I send, of course, the function describe the image in base64, and what I'm getting as a result is a single neutral product sentence, for example, the garment type, the color, the pattern, and one notable detail, so we don't have prompts or any marketing language. Then what I am doing is to run a second very small text only call that is called categorize from description, and simply what it's doing is to map that sentence to one label from my predefined categories, like we have, for example, t-shirt, dress, sneakers, whatever. Then we have the orchestration function that is just describing the images with category to a step. is making a loop over the image data frame, and it's creating the description and the category columns if they don't exist, of course. So it's skipping as well the rows that are already filled, and it's handling the missing base 64 in case that there is some problem. So you see now the result we have in the data frame. Well, this is part of the data frame, it's not complete, but we are showing the columns of the file name, the category that we got from OpenAI, and also the description. And once that we have all the data ready, we need to make the connection to the database 26AI with the library Oracle DB, as we were mentioning before. And what we are going to do here is just to manage the connection details via an environment file. This is the recommended thing here just for the demo, so you can see that everything is there. Here we have the details directly, so you see that we are passing the database user, the password, the service name, the wallet location, the password for this wallet, etc. So we can connect to the database. So we open the connection with Oracle DB with all the information that here you see it in plain text, but should be in an environment file for security. And we can start executing and creating the tables. So, well, this is just a drop just in case that it was existing before. But the thing is that we need to create the table. In this case, it's demo image vectors with our homemade pictures. With all the columns that we need to store all the information that we prepared before with the embeddings and the vectors. And here you can see how we are introducing all the data inside the database. So after that, we are building all the list of the rows from image data frame, and we are converting each Python list of floats into an array. This is very necessary for the vector type, and the last thing that I do is just one execute many bulk insert, so it's followed by a commit. And yeah, you can see that finally we can see that we inserted 99 rows. These are all our pictures with all the data prepared. So from this point, we can just check how it works. So we just call to our model to see how it is working. Of course, when you call to the model, you first need to prepare the picture. So you need to do the same as we were doing before, like decoding the base 64 or the bytes. And finally, once that you have your image prepared, you can execute the similarity search. This is a small function that basically is taking the picture and it's doing the preparation of the picture and sending this to the model to get the similarity. So here you can see very nice socks that we have from our colleague. And you will see that the similarity search is working fine and finding the similar items. In that case, it's taking some socks also from The Simpsons, Homer Simpson, another type of socks. In this case, if you are wondering why it appears also the same picture, is because I use one that is already in the database, but generally if you upload another one, of course it's not going to appear the distance. So you see that it works quite well. Of course, here the distance that to this one that is pink, there's the input picture, it's negative, so that means that works very well, and the others is very, very small. So here you have the similarity. And with that, now that we have the table in the database, Roxana is going to show you something enhanced and how she build the application with more functionalities. Over to you.
We took all the data that Christina prepared. Special thanks to our amazing team who took some time to take pictures of their own clothes. So we have nice data to show you today. We built the application in Apex. And as I mentioned, we have 3 main pages. We have the first page, which is doing similarity search by images. And let's say I want, let me show you first the image. I want to buy a Romanian traditional blouse, but I have no idea how this is called. Maybe Christina wants to buy because she has seen one when she came here a while ago. So she doesn't know how this blouse is called, so she can take an image and she can put it in the application and find similar products that looks like this one. So let's do this. I will drag and drop the image here, and once I do this, what will happen? Apex will generate embeddings using the clip model, and it will get me similar products. You see, all of them are Romanian traditional blouses. Or maybe I want an Oracle hoodie that looks something like this. This also belongs to Christina. So let's see if we have other similar products. And we have 3 other hoodies or t-shirts that has Oracle and Red Bull encryptions on them. So let's see how we do this. We have this item here, which is an upload image. We store it in the Apex application temp files, and once the item is changed, we resubmit the page. So we do the search again. Let's see how the query looks like. Let's make this bigger. I hope you can see it. So we are using the Apex API that I mentioned during the presentation, get vector embeddings. We use the blob content, the image that we have uploaded in the application, and we are using the clip image model that was configured at my workspace in the vector providers. So we generate the vector, we call it image vector, and then here is the table where Christina uploaded the data. So we calculate the distance between the vector that we generate on the fly. We compare it to the vectors that are also generated with clip model and are stored in the database, and we order them by the distance. This is how we get the closest results. Now, let me quickly show you how the vector providers in Application Builder, Workspace Utilities, all Workspace Utilities, we have the vector providers. This is the place where we can define our providers. It's very easy to do so. You select the provider type, which can be either a database on an NX model that we generated and loaded earlier in the database, GenAI service, or a custom PL SQL. And once you select, you just choose your model. We have several models imported, and that's it. You refer to the static ID that you put here, and you are ready to use it. Now, let's go back to our application to see what else we have. We use several models for today's demo. We also use the All-Mini LM model. This is for text embeddings because we want to search by description. So what we did, we took the descriptions of each product, we generated embeddings for them, and we implemented this item that again will be converted into a vector and compare it to the descriptions, and it will get us the desired results. So if I search here by shoes, for example, I will get well, all the shoes that we have in the database. We don't have that many, but you see here in the description there is no shoes word. We have sneakers, but the similarity search worked very well and identify these as shoes. Let's see what else. We can search for flowers, for example. I want clothes that have flowers, and you see we get several results. Here we have flowers in the description, but for the others we have floral patterns or floral embroidery, and so on and so forth. If we compare this to the classic search, if I search here flowers, for example, it will return me only the first product, because this is the only one that has the flowers word in it. So this is the difference if you are using regular search or a vector search. Then we have the clip vector search. We have generated in the embeddings of the images inside the database using the clip model. How this clip model works, this is designed to generate embeddings for both images and text in a shared space. So the semantic similarities can be measured directly. you can search by text here, and it will look also in the image, and the other way around also. So let's say for clip, I want to search, let's say, cool clothes that has glitters, for example. Glitters, okay. Sorry, I have this filter there. So if I search by glitter here, I will have all these nice clothes that are really shiny. So it took this word and it searched in images, and those images has as their features the glitter. What else? We have a funny example to show you, like Pink Panther. You see, and we got this t-shirt that has a Pink Panther on it. Again, if we search by flowers, we get all the images that have some flowers on top of them. Now, let me show you how to do this. We have this item, which is a text field. Again, when we change the value, we resubmit the page. And what happens in the background? We use this time the clip text model to generate embeddings from the description text that we put there, and we compare these embeddings, the description one, with the vector clip vectors that we have for our images. Okay, let's see what I have here in the favorites. I have this Oracle t-shirt. What I will do as an owner of the online shop, I can recommend similar products. Maybe you also like this one, and I discovered that I don't want a t-shirt, I want a hoodie, and this is a very good example for me. This one is based on the ResNet embeddings that Christina generated. So let me quickly open the page. Okay, so I'm using the vector. This is the column where Christina saved the vectors generated by ResNet. So I have either the option to use the vector generated from data science and compare them, or generate on the fly and compare them also. Now, the shopping cart is empty, but let's say I want to buy this pair of socks because they look very nice. They are so pink. In the moment when I want to add something into the cart, I say frequently bought together. So in the same fashion, I'm trying to make suggestions for the end user so they can buy similar things, or maybe they discover they like this more rather than this one. So once I add to cart, I will go here, and before checking out the order, I display the same screen and I say, you might also like this one. Hey, please buy more, not only this one. I proceed to checkout, and now I have my order with the nice socks. This is what we wanted to show you today. Now let me move back to the slides, to the conclusion and next step, what you can do. You now have a visual similarity with vectors in the database. You can do personalization with user profile vectors like I did in this example. You vectorize the user favorites, and based on their profile you make them suggestions that might help to choose the right products for them. We recommend you to try this combination with OML on NX and import the models in the database, and also extend to multimodal text plus images like we have in our demo, or use them in a different domain. Now, Violeta, I will hand over back to you.
All right.
To show the resources. Thank you so much.
I would like to thank you for attending today. Thank you, Roxana and Christina, for presenting. We hope that everybody in the call enjoyed the session. In case you did that, please vote in the survey that will appear once we end the call. We hope to see you in the next ones and enjoy the rest of the afternoon. Bye-bye.